Okay, so in solving these problems, so I have two problems that has to do with a triangle method of solving vectors. So we are going to start from number one, and then we can see how we can use triangular method to solve this problem. So when we look at this problem, we can see that we have two forces here that we are going to solve. So we are going to find the value of F, as well as the tension here. So, and then in question number two, we can see we have T1 and then we have T2. So all these things are what we are going to be looking at here, and see how we can solve problems here. So in analyzing the questions from what we have done previously, so what we need to do here is that we have to start with the vertical straight line in terms of question number one. So we are going to start with a vertical straight line. So that is a vertical straight line, and that represents what? 12 Newton. So this is 12 Newton. So this force is actually pointing eastward, and this is northward. So this is westward. So this is all that we needed to know. So in representing that, so we can see that the vertical force is actually acting downward. And then when we look at this point, we can see that the force here is between north and what? This is going to be our north, this is going to be our west. So how then do we relate it here so that the T here will be actually between what? North and the west. So that is what we are going to do. So since the force is acting downward, so we are going to look at it this way. Northwest, okay? Northwest, okay? So this is north, this is west. So our force is actually going to be like this. So our force is going to be this way, northwest. Okay, this is north, this is west. So this is going to be our T. This is our 12 Newton force. So, and then this other force is actually pointing eastward. So we are going to draw it this way. So we are going to draw it this way, and this represents F, this represents T, and this is the downward force. So, and this is the right angle. So when we drew it like this, we can actually see that this is exactly what's represented here, because the 12 Newton force is acting downward. This one is between north and the west, and that is what we have represented. And the angle between it, the T with the vertical, is what? 30 degrees. So we have here 30 degrees. Okay, so we'll just put down that. So how then do we solve the forces? So we can see opposite over adjacent, and that is tan. And then we can equally say adjacent over hypotenuse, and that is cos. Whichever way, we will always get the answer. So in solving for for F, so we can say opposite over adjacent, and that is what? Tan. So we are going to say tan 30 is equal to F over 12. So that means that F is equal to 12 multiplied by tan 30. So, and that gives us the answer. And then solving for T, so we can say adjacent over hypotenuse, and which is what? Cos. So we can say cos 30 is equal to 12 over T. So that means that T is actually 12 over cos 30. So let us just do it up here so we can understand. So T is equal to 12 cos 30 degrees. So, and that gives us the result there. So question number two, we have this. So what we need to do here is that we need to do some constructions here. So construction like constructing a vertical straight line to meet the point here, okay? So that the angle between the vertical here will be 30 and the angle here will be what? 60. So the weight of this block is actually 20 Newton, and that is acting downward. So from there, we can just draw this, and we'll label it 20 Newton. So looking at that, we can see that the force here, T1, the tension T1 is actually between north and west. This is westward, this is eastward, this is southward. So between north and west, so this force T1 can be found. So, and this is why we are going to do it this way. So we just assume that this is west, this is what, south. So, and then we have to draw force like this, and that represents T1. Okay, so we are going to continue from this point, this end. We are going to continue from this end. Okay, so continue from this end, we can see that the force here, assuming this is south, this is north, this is east, this is west. So the force T2 is between north and east. So between north and east here, so we are going to have another force here, and that represents T2. Okay, already we saw that the force here is what, 20 Newton. So the angle between T2 and the vertical, the force T2 and the vertical is 30 degrees. So T2 and the vertical is 30 degrees. So we just label here 30, and then the other one is what, 60 degrees. So if this is 60, this is 30, so this is going to be 90 degrees. Okay? So if this is 90 degrees, that means this is going to be a right angle triangle. So from there, we can actually solve problems using any of the trigonometric ratio in solving problems there. So we can actually say opposite of hypotenuse here. Opposite of a hypotenuse can solve that. We can actually say adjacent of a hypotenuse, since this is a right angle triangle. So that is how to do that. So in solving T1, we will just say adjacent of a hypotenuse, adjacent of a hypotenuse, which is cos. So we'll say cos 60 is equal to T1 over 20. So that means that T1 is going to be 20 multiplied by cos 60. So, and that gives us the answer. So, and then coming to T2, T2 is actually opposite of hypotenuse. So, which is sine theta. So that means that sine 60 is equal to T2 all over 20. So T2 is going to be 20 multiplied by sine 60. So, and that gives us the result. So once you multiply 20 by sine 60, you get the answer. And then this is 20 multiplied by cos 60, and that gives us the answer. So analyzing problem using triangle method is the easiest way of solving three forces acting at a point, and without any delay, that can resolve any problem regarding such a method. So that is all that we have for now in this topic. So thank you.